All right, what's up, guys? In this video, I'm going to pick up some calculus here, and we're back on the topic of limits. So we're just going to evaluate this limit as x goes to 0 for 1 over 5 plus x minus 1 over 5, all divided by x. So the first thing you do anytime given any limit is just try to plug the value in and see what happens. If we plug the value in here, notice we'll get 0 over 0, which is an indeterminate form. Make sure that you keep in mind the difference between an indeterminate form and a limit does not exist. A lot of people get the two confused. An indeterminate form does not mean the limit does not exist, just means that you need to come up with some clever way of finding the limit. There's a couple different ways that you can go about doing it. You can expand out expressions, you can factor sometimes, you can cancel things out. If you're dealing with trigonometric limits, you can use trig identities, and there's obviously L'Hopital's rule as well if you get into a situation where you need that. So make sure you know the difference there. So what I'm going to do is I'm going to go ahead and see if I can get common denominators up here. And because in order to subtract fractions, we need a common denominator. So notice that we have 5 plus x here for our first fraction as our, that's the denominator for our first fraction, and the denominator for our second fraction here is 5. So the least common multiple of those two denominators there would just be 5 times 5 plus x. So what we can do is we can get common denominators, and that'll help us out a little bit. So to get common denominators, what we'll need to do is we'll need to multiply the fraction 1 over 5 plus x by 5 in both the numerator and denominator. So we'll get 1 over 5 plus x. I'll multiply the numerator and denominator by 5. And what that does is it just gives me 5 over 5 multiplied by x plus 5. I'm going to write it as x plus 5. I hate 5 plus x. I just hate the way that looks. Okay. And for our fraction 1 over 5, we'll just multiply both the numerator and denominator of that by x plus 5. In that case, we get x plus 5 all over 5 times x plus 5. And now we got common denominators and we can subtract the fractions. So we got 5 over 5 times x plus 5. We'll subtract that from x plus 5 all over 5 times x plus 5. And we'll get negative x over 5 times x plus 5. Because remember, when we're subtracting fractions or adding fractions, when we have the same denominator, the denominator stays the same. We don't do anything to the denominator. We're just dealing with the numerator. So that's what we'll get. And how does that help us? Well, we'll get the limit as x goes to 0, and we'll have negative x over 5 times x plus 5. We'll divide all of that by x. And if we simplify that, we'll get the limit as x goes to 0. And this is simplified down to negative 1 over 5 times x plus 5. Now we'll plug the 0 in again. And if we plug the 0 in again, we'll simply get negative 1 over 25, which is the limit. Because if we stick in the 0, we'll get, negative 1 over 5 times 5, which is 25. So we'll get negative 1 over 25 is the limit. And that's your final answer. So your final answer here for this limit, we'll say L is equal to negative 1 over 25. All right, so hopefully that made sense. So let me know if you got any questions about how I got that answer. I'll see you next time.